Hello. Now we'll study one more property of conductor, and that property is what will happen to the extra charges. When I provide the extra charges to the conductor, what will happen to that extra charges? And the thing which happens with that extra charge is, these charges, these extra charges, they always resides over to the surface, obviously after achieving equilibrium. So at equilibrium, these charges, you will always find these charges occupying the location onto the surface. Now why that happens? Meaning when I'm providing the extra electron to this conductor, why those extra electrons are coming to the surface? So you see, when we talk about the potential energy for any kind of structure, the potential energy is inversely proportional to R. For any kind of structure, there will be some geometrical factor also, meaning we have the potential energy formula for point charge. We have that for different structures also, but whatever structure you see, the potential energy is inversely proportional to the R, where R is a distance from a fixed point. Generally that fixed point we define as the center. In this case also, that fixed point might lie somewhere. It might lie inside of this conductor. So the potential energy is inversely proportional to R. So if R will be more, potential energy will be less. As the R will increase, corresponding to the same amount of charge, as the R will increase, the potential energy will go down. And one thing we know about the system, each and every system wants to achieve the minimum potential energy level. So for all system that we know from the very beginning, for all systems, and I'm not just talking about the conductors, or I'm not just talking about the electrostatic. That was true in case of Newtonian systems also. For all systems, they wants to achieve minimum potential energy. They wants to achieve minimum potential energy. So you see, if this electrical system, which is a conductor, if it wants to achieve the minimum potential energy, the moment you decide the charges, you cannot change the charges. The moment you decide the conductor, you cannot change the shape. The only thing that can change is the R. R is how distributed these charged particles will be. So basically, the moment you provide the extra electron or extra proton or extra anything, extra charges, the moment you provide those extra charges, those charges will try to move away as far as possible from the other charges. So just talk about 2 electrons. So if I'm having 2 electrons, these are the 2 extra electrons I'm providing to the system. So due to this extra electric repulsive force, these charged particles, 2 electrons will try to go as far away from each other, and they cannot move, they cannot go into the air. What will happen? They will go to the surface, respective surface. You provide more charges, they'll also go to the surface. So that is the reason. This system, whenever you provide the extra charges to the system, this is a conductor system. Whenever you provide extra electron, extra charges to the conducting system, since in case of conducting system, these charges can move. In case of insulator, they cannot move. That's why we were not talking about this thing at that point of time. But here, these charged particle can move. So the moment you provide the extra charged particle, they will try to move as far away possible from each other. And that's why these charged particles, when you will look at these charged particles, after achieving the equilibrium, they'll always be at the surface. I'm not saying they will be symmetrically distributed. I'm saying they will be at the surface and surface only. Okay? So that's the thing. So one more property we learn, and that property is if you are going to provide the extra charges to the conductors, these charges are going to be the surface. Now there can be 2 types of surface. This is one surface, but inside this is our conductor. If by any chance you are having one cavity inside the conductor, this is my cavity. You see, in this case, including the cavity, there are 2 surfaces. This is one surface, I'm calling it S1, and this is another surface, I'm calling S2. So if I'm going to provide some electron, these electrons have 2 places to go. They can go for S1 as well as S2. Now where they are going, we don't know. If you want to calculate how much charge is going to surface 1 and surface 2, we will have to solve this question using the Gauss law. We'll learn that in the later lectures. But right now I can only say that if you are going to provide the extra charges, they'll be going at the surface. If there are one surface, they'll go only at the one surface. There are multiple surfaces, they will get redistributed based upon the physics of that question. Okay? Thank you.